Factoring x squared minus 6x minus 16, we're factoring trinomials. So we want to have two binomial factors that give us this trinomial. So since there's no leading coefficient on the x squared, we can just ask ourselves the question, what two numbers multiply to negative 16 and add to negative 6? So we want to look at the factors of negative 16. 2 times 8 seems to fit. So then I can write it as x minus 8, x plus 2. Okay, and we can always check this by expanding this out. We want to FOIL this out. The next one here does have a leading coefficient of 2, so it's a little bit harder. So we want to use the property that if we multiply the first and last terms, it helps us decompose or split up the middle of negative 1. So we can do that the same in our box multiplication. If I multiply the first times the last, I get negative 20x squared, and this allows me to split the middle. So this middle term, negative 1, must come from the sum of these two parts. So I can then ask myself, what two numbers multiply to negative 20 and it's going to give me the sum of negative 1? Well, that's going to be negative 5 and positive 4. And once I've done that, I've got the right area. I just need to now find this common side length. So I can just go along my vertical line here. And that line, the common side length is going to be negative 2x, or sorry, positive 2x. So I'm going to have positive 2x. And along this vertical line here, we have a common negative 5. So we're going to end up with negative 5 as my common factor or my common side length for this part. And then I can divide or just do the same thing to get the width. So common x, and I have a common plus 2. Again, I can check by multiplying this grid out, see each of the area pieces match, and they do. So my factoring is 2x minus 5, x plus 4. Oops, not plus 4, that is plus 2. Okay, and again, expanding this all out will give me the same result. So for the next one, we want to do the same thing since there's a leading coefficient of 3x squared. So the 3 makes this a little bit harder to factor, but again, if we use this diagonal property, that this diagonal multiplies to negative 30x squared, and we know that the other diagonal here must give us the middle term here. So we want to use that product 30 to decompose the middle term minus x. And when we do that, we end up with two numbers that multiply to negative 30 and add to minus 1 is going to be 5x and negative 6x. Now, it doesn't matter which way I do it. Either way I do it, this is factorable. So if I just take my common factor horizontally, there's not a common 3 here, so it's just going to be a common x here. Along the horizontal, along the bottom square is going to be negative. There's a common negative, and there's a common times 2. And then along the vertical, we have 3x, and there looks to be a common 5 here. And so we'll take the 5 here. And the negative came out with the double negatives. So there's our factored form. So we're going to put this in brackets. 3x plus 5, x minus 2. That gives us the factored form of this.